Alright, good morning everybody. Welcome to our senior design presentation for the fall of 2016. My name is Jonathan Loray. My teammates are Jason Soto and Christopher Perez. And today we're going to be talking to you about a creation of our own invention called the Bmw Umbrella. It's going to provide weather protection for two-wheel drivers. So a big problem that we have in the world right now is that a lot of people can't afford automobiles or enclosed vehicles or four-wheel vehicles. And as a result need to resort to two-wheel types of vehicles such as motorcycles, scooters, bikes, etc. to commute to work or to travel, etc. The problem with this is it lacks any sort of aerial protection. Rain, intense sunlight, snow. There's not really any sort of guard for people like that are in those types of situations. And these types of vehicles tend to be very shaky. They're very dangerous when driving on the road. If a collision happens, accidents can be detrimental. And current solutions to trying to fix this problem, not having any sort of rain protection or protection from the elements, is that a lot of the solutions we currently have are very cumbersome, sometimes too expensive, and they're not very effective at completing the job. So our solution is we want to create a shield that's going to be universally compatible with all two-wheelers, bikes, scooters, motorcycles. It's going to have a deploying shield that's going to cost about $300 to develop, hopefully $100 if mass-produced. It's going to be very lightweight, durable. It's going to be completely see-through and clear. It's going to include windshield wipers for maximum visibility. And it's going to be extremely aerodynamic in shape.
Right, so existing solutions to a two-wheeler's weather susceptibility are, first off, is the poncho. It is a simple tarp that covers both the driver and the vehicle. This is a very cheap solution, however it has some downsides, such as that while the driver is moving, it tends to flap in the wind, and it doesn't effectively cover the face, which still allows droplets to hit the user. Another solution is an attachable umbrella, which attaches to a vehicle as described in this picture. However, the downsides of this device is that there's a hole directly in the line of sight from the driver, and it's less effective while traveling at higher velocities. Other solutions include a glass awning, which can be bolted onto the underside and mounting points of the vehicle. This glass awning is better than the previous umbrella because it provides, it also has a windshield wiper to aid in visibility during the rain. Also there is the motor car, shown in the bottom. This device is not technically a two-wheeler, but it does use tarp and vinyl covers to be able to protect the user from the elements. And lastly, there is the Bmw C1, which is a vehicle that it has the same implementation as the glass awning. However, it's been built into the frame of the motorcycle. Future solutions, which are more expensive than what our target audience can naturally afford, are the EVO vehicle and Litmotor C1. These devices are fully enclosed and can protect the user from all types of elements and also can be climate controlled on the inside. So for our design after analyzing the previous designs, we came up with a couple numbers that would help our device fare well and compete against these other devices, such as it needs to be affordable, around $100 to be able to compete with the glass awning and umbrella solutions. It also needs to be self-deploying to allow the user to activate it even while driving. We're aiming for a 5 to 10 second deployment time. It needs to be adaptable, able to fit about, we're aiming for 75% of all two-wheel vehicles. And it needs to be able to be durable, able to withstand a constant wind speed of 70 miles per hour, which takes into account forward velocity plus a headwind. And they last about 5 years, which is the average lifespan of the scooter.
So of our three designs that we came up with, our first one, it's the most compact surface area-wise towards the front and helps open up towards the top, increasing the size towards the back for the user. It provides a very large surface area for protection, just so the user stays clean and dry. And it's very aesthetic looking. Of our three designs, it's very sharp looking. However, it does tend to obstruct the lights of certain two-wheel vehicles. Sometimes the lights can be mounted towards the top of motorcycles, and this has to be mounted towards the frontal body of the motorcycle or scooter. And while it's deploying, it can create some issues while driving because of the differences in lighting that can happen while driving. And it's a very complex mechanism. We haven't actually tried to see if this will work in the real world just as yet. Our second design is a sort of telescopic design that opens up with plates towards the front and would deploy as such with a handle to the top and can be manually deployed. Of our three designs, it's the most durable. However, it's extremely heavy and it's difficult to deploy while driving because it would have to be manually deployed. It's very sturdy though otherwise. And the design we're probably going to go with is a design that mounts towards the bottom of the seat of the vehicle, and it's going to deploy from the top to the bottom. So it'll be somewhat of looking like a semicircle towards the back, and then can be deployed at the front. As such, we're hopefully going to see if we can get that automatically done. It provides the most amount of coverage. It covers all sides of the user. The other two designs don't. They have the left and right sides exposed to the elements. It's not as compact as the others, unfortunately. It does take up quite a bit of surface area, and exiting the vehicle can be a bit of trouble because you'd have to put away the design first before stepping off the scooter.
So we ran some simulations to determine what kind of forces the canopy would experience during travel. And here you can see our airflow simulation and distribution of surface pressure. Here are the actual numbers for the simulations during a clear day with travel speed of 60 miles an hour, which is typical for most higher-end scooters and definitely motorcycles. You can experience a force of about 89 to 135 pounds downwards due to the incline of the canopy, and backwards due to the wind pressure. On rainy days, it's lower, even though the driver is traveling through the rain, which adds extra forces to the canopy. The overall speed is lower as typically drivers going on the rain tend to reduce their speeds.
There are many different engineering standards that we have to observe in order for our project to be effective. First and foremost, we're going to follow the National Society of Professional Engineers Code of Ethics to make sure that all of our data will be presented as is without any modifications. We will be honest and impartial with any data that we choose to present. Standard industrial tooling and materials. For bolts and screws, we're going to use certain standards that are already found out in the world. For the bolts, we'll use the ANSI ASME V18235 1979 standards. For screws, we're going to use the ISO 1059 2012 standards. For the steel frame, we're going to be using ANSI grade steels, and for non-steel materials, we're going to be using materials found in the ASTM catalogs. After further research into the subject, we figured out the best possible materials for our project. We're going to be using 6061T aluminum for the length of the frames of the project, since it is used in aircraft and it has been proven to be strong in high speed winds. For the mounting frame itself, we're going to be using the standard grade steel in order to try to make it as close to standard as possible. For one of the sections, we're going to be including vinyl sheets, and the reason for this is because we want to include windshield wipers in this design. It's important because if not, the driver will not be able to see during the operation of the vehicle during rain. 100% polyester fabric will be in between the frames, mainly because it is water resistant and it has good enough properties that it won't corrode during the rain. For the restricting belt that goes around the back frame of the two-wheeler, we were thinking about using nylon with a rubber layer inside, in the inside surface of it to increase adhesion at the base, make sure it doesn't drop. We may have to have some standard custom parts for our project. When this is necessary, we're going to be making some engineering drawings of these standards. So we're going to be using the ANSI format along with the SI and English units when making these drawings. Federal standards are the most important part of our project, since without them, it's going to be very difficult to have this in the market. The National Highway Traffic Safety Administration outlines all the standards that we need to be using through the Federal Motor Safety Vehicle Safety Standards. Mainly, we're going to be focusing on a standard called the 49 CFR, which has to do with protection against crashes or accidents. Mainly because our project is protecting the top and sides of our user, we have to make sure it's strong enough to withstand an impact or at least not be in the way or potentially hurt the user even more if it wasn't on.
So just to wrap things up, I'm going to talk about the global considerations that we have for our project. How can our project work on a global market? First of all, it's got to work for at least 75% or at least as high a percentage we can for all two-wheelers. There's so many types of models and makes out there for bikes, scooters, and motorcycles. We have to adapt to all types of styles. We have to make it really aesthetically pleasing. It's got to have different varying colors. It's got to look sharp. It's got to look good. We've got to make sure not to include any sort of perhaps offensive religious symbolism that would prevent a country from outright buying it or perhaps banning it altogether. Weather, there's weather all over the world of different kinds, rain, intense sunlight, snow of different degrees, and we have to prepare for a decent average or medium of that. And it's going to be extremely user-friendly. Installation is very simple, maintenance is very simple, and we're going to also include a manual that has multiple languages to accommodate all countries, or at least the majority of the most popular languages. Now we're going to open for questions.
I have a couple of questions. First one is, have you considered crosswinds on your analysis?
Considered
Crosswinds.
crosswinds?
So you analyzed the headwind.
Mhm.
Have you also thought of a tailwind, even when you're stationary, or highway crosswinds?
Yeah, we have thought of analyzing the canopy while experiencing crosswinds, because that would actually put different forms of strain on the canopy. However, we haven't performed those simulations yet, and we thought that probably the highest stress would be caused by the front headwind plus forward velocity, so that's why we included those numbers in the presentation.
I can tell you you're going to see your highest stress from crosswind. Usually that's where you have an unbalanced load on one of the sides of your structure, and you might be surprised on what you find when you do that analysis. The second thing you should consider is gusts. Constant wind speeds you might be designing for, but when you see 20 mile per hour winds and then it's gusting to 40 or 50 mile per hour, and it's intermittent, you might want to understand what happens to your structure if it encounters that situation. The second thing is hail, or any type of particle, right? Rocks flying off of the back of a truck. You might want to consider what damage tolerance your material has. Also visibility. I ride a motorcycle, and the main thing that you're looking for with any type of protection is visibility. What the water does on your canopy, is it shedding enough? Does the material, as it gets used, does it start to fade, or does it become, I forgot the exact word, but do you start to see the scratchy or opaque, there we go, or yellow? So these are things you might want to consider when you choose the material for your canopy. And last, is there any reason you didn't choose composite instead of aluminum?
Composites are harder to work with, and we have limited machining capabilities here at EC. So we figured it'd be easier to use aluminum as general instead of having to use composites.
Okay.
Yeah, the biggest concern I have is lift. If you're doing 70 mile an hour and you have to start pulling the speeds down, next thing you know, you've got a wing, you've got wheels off the ground. And how do you manage the fact that you're going to impact where the centroid of the bike or the two-wheeler is by this design? Because the bikes were designed with a known centroid. So
We're planning on targeting perhaps a 50, 60 mile per hour max for deployment. This wouldn't be something you'd probably deploy on the expressway. We would definitely like to have that done, but that obviously can create a huge problem with lift as it's coming down. We do want to make it automatic, and we're going to try to make it as thin as possible so that as it's deploying, it's not going to catch too much, wind. It's going to try not to be too resistant.
Parachutes are pretty thin.
Yeah, that's also true. But as it's coming down, it should come somewhat at an angle. It's not gonna come completely down to the front, but it should start just above the head, 90 degrees, and it should come downwards. But we'll definitely look into that and see how that would affect. I'm sure that's a big concern.
Mind if I follow up on that question as well? When the device is fully deployed, it actually exerts a downforce on the vehicle. However, I was planning on running step-by-step simulations with each deployment rate to see what kinds of forces were developing as the device was deploying.
So actually, following up on his point, this is my opinion. Deploying anything, or just doing anything while you're traveling on a motorcycle is highly unsafe. So I honestly think the best way would be for you to deploy this when you're stopped and latch when it's stopped. Lift is, I completely forgot about that, but you also have to notice where you're attaching this, what kind of loads are you putting on your bike to? You're going 60 miles an hour. What kind of is your rear wheel now losing traction? Are your contact surfaces now not the same as what the bike was designed to? Also, I'm not sure how wide this is, but the main benefit of a bike is the lean, right? So if now you're limiting how much you're leaning, you're also limiting the capabilities of the bike as far as turning. Something else I saw in your presentation is, even though you say this should apply to about 75% of bikes, you only showed scooters. So there are other types of bikes that might show a little bit more problematic with this application.
Yeah.
So maybe try and, there's a lot of scooters in the world, so maybe just try and target that market rather than just saying it's applicable to all motorcycles, because then you're going to have compatibility issues.
Yeah. To answer your first part, something we didn't mention in the presentation is that as opposed to having it towards the top, we were also thinking of having it stationed in front of you, so that as when you're driving at these high speeds, and of course having it above your head could be very dangerous. If it's on the front, we can have it deploy backwards so that it kind of goes with the wind, and in fact maybe the wind can even aid in deploying it. So that's something we didn't mention, but I think that could potentially help with the lift issue. And the compatibility issue is a very large issue. There's so many types of makes and models. Ideally, this is for the person that doesn't have too much money to spend, so perhaps it wouldn't be leaning towards more motorcycles since they can maybe range a little more in shape and size, but scooters generally have a geometry to them that's similar somewhat, and bikes as well. You're not going to have a huge bike with big sides or anything like that. So as long as we can get it, fastened to the bottom of the seat, and it can have a decent width to kind of cover a general spectrum. More so towards the market of people that can afford higher end stuff. So scooters and bikes, we will probably definitely focus on that. Motorcycles is sort of a plus.
Right. I would just say I would like for you to focus a little bit more of your research into safety as well, because your design is, I like it, but to me there's a little bit of hesitation when it comes to safety, especially that deployment when you're driving.
Yeah.
The guidance. If you targeted bicycle, it's a great project, and it's a lot simpler. Once you put that motor on it, put yourself on roads, it's a very different, on high-speed roads, it's a very different problem. So, that's guidance, take it for what it's worth, but you make your problem a lot less complicated if you're using a human-propelled vehicle.
Yeah. The main thing we're trying to accomplish is just see how far we can get. it's not going to be as effective at really high speeds, and of course when you introduce the motor, it does make things a little more complicated. But you know, as a scooter, it's kind of like the second line of transportation for people that can't really afford to spend that much. We want to see if we can reach that threshold, and it would obviously appeal to a lot more people, you know, who can't afford to drive slowly on a bike but need more of a scooter. But yeah, it's definitely be a lot more challenging.
So maybe limit your design space a little bit, right? Just maybe say this application is usable for cities, sort of like, you know, or countries like Italy, where cities are high on scooter usage, but most of them are going between 25 to 35 miles an hour, not 60 miles an hour. So maybe just readjusting your design space might be another solution.
We intend on getting a model scooter or something like that to see how we can baseline our measurements to that scooter, and so we can see if we can have a tolerance of about a few so that it will have a good application to the remaining scooters.
Will there be any wind tunnel work?
Yes, we were planning on using the wall of wind when we
yeah.
have
Well, we tried getting actually access to the wall, and sorry, Chris, but I just don't want to like say stuff that I, you know, make promises that we couldn't actually get. We tried looking into the wall wind, however, it's extremely expensive, and there's no wind tunnels at the FIU besides that are large enough to cover this, because this device is approximately like 3.5 feet wide. So if it could fit into a wind tower, it would have extremely low clearance, which would mess up all the results. So instead, we're planning on building our own test setup and attaching it to a pickup truck and bolting it down. We're not going to test this in anywhere populated. We're planning on going to remote locations such as the long stretches of road in the Everglades, and just we would be on the side of the road, and the vehicle would be driving down, and we would observe its behavior.
I would advise you against that, and instead
Completely against that.
scale it. I would maybe scale it down to where you can manage it in a different type of testing. But I would advise against you doing that type of dangerous testing.
And if you did that, do it unmanned. Do not put a person in that.
We'll put a crash dummy or something.
Don't put yourself in harm's way.
No.
Thank you for
Well,
the
we just
advice.
could you talk a little bit more about your timeline?
Yeah.
So I mean, first we start off with more research. We need to, you know, figure out the forces of wind and rain on you know, the general surface as you're driving at certain speed limits. You know, materials research, cost research. A lot of it was mainly designing towards the beginning. We haven't yet found a you know, final design. This is, we think, a bit close, but we want to make it a little more aerodynamic, and we want to add some more features to it, such as LEDs and backlights to make it more visible. But as we continue forward, we're gonna, you know, obviously go into the prototype building stage, probably around maybe this winter that's coming up. We're gonna probably focus on trying to make a final design as quick as possible, and then after that, we're gonna go into, you know, seeing how can we start building this thing. We're gonna try to do that before the beginning of next semester, and as the semester comes through, we're gonna probably be spending the majority of our time on building and testing and trying to reevaluate what exactly it is that makes this design functional or not functional.
When are you going to start testing?
Probably, we want to get that done as soon as possible, because I mean that's when problems can arise earliest. We want to try maybe the first month of next semester. So we're going to obviously have to be working on this during break, very much so. This isn't really something we can just hold off until next semester. It's a lot of work. So probably hopefully within the next month or 2 months starting of the next semester, we'll probably get to testing it and hopefully have it finished, the prototype.
Okay, thank you.